Let's go to the next presentation titled Automated White Haze Detection in Tempering Process. There will be two speakers that I would like to invite to the stage. First speaker from Glaston, Riku Färm. Riku is working at the moment as a director of product management and sales engineering for heat treatment in Glaston and has an extensive experience in tempering and lamination processes. And Riku will keep the presentation together with Peter Pfannenstill from company Soft Solutions, and Peter is the founder of Soft Solutions and has a long experience already in different kind of quality measurement in glass processing. So, gentlemen, Riku and Peter, welcome. And huge applause, of course, for the gentlemen.
Good morning.
All right, I think, do we have a clicker here? There we go. So, hey, good morning, everybody. As introduced, my name is Riku Färm. I come from Glaston, and today it's my pleasure to discuss with all of you the topic of how white haze can be automatically detected. And this presentation, as introduced, will not be only by me. So with me I have Peter from Soft Solution, and this has been a long joint project for us, so very eager to have Peter on the stage with me. Before we get to the actual topic of how do we detect white haze, so let's just quickly cover that what white haze actually is. So white haze itself can be categorized as kind of foggy or stripy hazy areas in a tempered glass. You can see here on my left-hand side, your right-hand side, an image of a glass that has been placed on the floor on a mat to make haze more visible. And the haze here has been marked with a black marker to indicate where it is. And I was actually struggling a bit to find a good quality image of haze. And I realized that that actually gives you a good idea that why white haze detection is so difficult. So as you can see from the image, even though it's there, it's very difficult to make it visible. And why does this happen in the tempering process? So very briefly, when glass is being heated, the heat expansion is causing the glass to bow slightly. And traditionally, people tend to temper glass so that it's a bit traveling on its belly on the ceramic rollers. And now if there's some dirt or chemical on the rollers, it's kind of natural that you're seeing some markings on the glass. And now the question with white haze then is that how visible does it become after tempering? And that's the main topic that we're here to discuss today. Why white haze is such a difficult topic in general is that there's multiple potential root causes. So when our experts are trying to solve the issue of white haze in tempering, the root cause analysis is the most important thing. It's very easy to jump to the wrong conclusions. It's difficult to see, so it's difficult to detect consistently. And then it's often, for this reason, only detected in the final installation location, which of course is the worst case scenario that you can have. And now, when we got together with Peter a couple of years ago to discuss that, is there something we can do about this? We decided that, of course, the first thing that we needed to solve is that how do we make white haze visible? And now Peter will next tell that what Peter and his team did at Soft Solution to overcome this very difficult issue.
Thank you, Riku. Good morning also from my side. Thanks very much for participating. So, as Riku said, we were forced to develop a hardware, a system to make white haze visible, to get nice images. And as it's common knowledge that if you want to develop a stable and reliable solution for an industrial vision application, it very much depends on the selection of the right illumination. And that's why we focused on this topic first. The other parameter, of course, is resolution. So as we were not aware of which kind of resolution is required, we started with a very high resolution first, which was in our case between 600 and 800 dpi. So, you know, normally a vision inspection system in the glass for the flat glass industry works with a so-called light transmitted method. So that means that on one side of the glass you have a light source, on the other side of the glass you have an optical sensor, and if there is any kind of disturbance on the glass, it means that the emitted light will be absorbed, and this can be measured and visualized. So what we started with, we played around with a couple of different setups. As you see on the left-hand side, we played around with camera-based solutions, we played around with linear sensors, image sensors. We did play around with different light sources, ring lights, LED light, different wavelengths, and so on and so forth. The very first promising setup was something you can see here. So you see it's a typical software development developer environment with a few Red Bull canes, which he played around with to do the first thing. But this was actually really one of the first promising setups we got to. So by developing the hardware, what was the key findings? White haze, we found, white haze is of course leads to a very, very weak darkening effect. So that means a standard light setup was not very useful. So we decided to develop a specific type of dark field illumination. And the crux again lies in the selection of the illumination, and not as very much mistakenly assumed in the resolution. So finally we got to the conclusion that by using a resolution of 200 dpi is more than sufficient to make white haze visible. So let me explain you the desired setup which we got to. So what you see here is a sketch of the setup, how it works, how we make it visible. So you see there is the so-called imaging sensor indicated as number 1, and the light source is indicated at number 3. The rod lenses, what are they used for? It is essential that the normal reflected light on the top surface of the glass does not overdrive the reflection of the white haze effect. And therefore we use these rod lenses to avoid that any other reflected light, normal reflected light, does interfere and again overdrive the reflection of the white haze. The glass in the middle and on the opposite side, it was very important to avoid that the glass, the light, the emitted light which passes through the glass pane on the opposite side of the glass will not lead to any kind of reflection or disturbance of the imaging process, and therefore we placed some kind of absorber material on the opposite side to avoid any kind of reflection. So at the end, we developed this setup, these sensors which we place overlapping along the entire width to got finally to the hardware which you can see here. So starting from the Red Bull canes to the final hardware which you see on the left-hand side. Riku.
Thanks, Peter.
Thank you.
All right. So first step is now solved. So we are able to make white haze visible. Then, of course, the very next logical question is that how do we then actually detect white haze? And the difficult part about haze, as I mentioned in the beginning, is that there's no standard about white haze. No standard is defining that this is good, this is bad, this is how you should be interpreting it. It's in a way very subjective. So depending on who is looking the glass, might find it to their eye more or less pleasing. And it's kind of elusive. And what I mean by that is that you're trying to find some hazy areas in the glass, which is a see-through material. It can be in different locations, the intensity can be different, and that's why it's so difficult normally to find. You can see here in this picture a very traditional way of trying to find white haze right after the tempering process. So operators gathering around the unloading table, using some kind of external light source, and then debating that is white haze there or not. So then the first question from this came that, okay, how do we actually evaluate white haze if it's such a subjective topic? And here, really what we decided in the first phase to do is that we need to gather industry experts together to give their opinion on the topic. So we did actual empiric studies. We had glass samples, different sizes, different kinds of hazes, and invited experts to review those, to give their own idea that how do they see the haze if they are even able to find it. And of course, one of the most important questions and comments then that was coming up is that, is the glass actually usable in the end use case that it's intended for? And that's of course the most important thing. And now the model that we created to categorize white haze really tried to capture the essence of this. Is the glass usable in the end use case? And the model that we created has 3 different categories. So kind of a simple way to put it. First one is called mild. The mild haze is something that if you're really looking for it, you have an external light source, a trained eye, so yes, probably you can find it, but most people will never notice this kind of haze in an actual installation. So normally, this is not considered to be any kind of an issue in tempered glass. The second category that we created is called medium. And medium is starting to be more visible than the mild haze. If you're looking even without an external light source, with close inspection, you're able to find it. But even this medium category is something that in most use cases would be considered to be perfectly acceptable and normal. Maybe somebody can find it there if they're looking closely, but in normal use, nobody will be paying any attention to it. Then the last category, which is perhaps now the most severe, is the strong. And strong is something that's clearly visible. This type of haze operators can normally spot if they are paying attention on the loading table. So it becomes more visible, and often also this would then lead to reclamations if this kind of glass is installed. So this is the model that we ended up with 3 pretty simple categories in order to make it possible to actually discuss objectively about white haze. And now, next question of course then is that we have a way to categorize. So how do we actually detect? Peter's system is giving great images where white haze can be seen, but it's still super difficult to actually distinguish what is white haze, even though we are able to have these guidelines on how to grade it. And here, technological development in general really played a role. So in the beginning, we did give it a try with different kinds of, say, traditional technologies, trying to detect where the haze is located. The biggest problem there started to be that you have all kinds of things visible on the glass after tempering. Maybe you have some fingerprints, you have some marks from the Kevlar in the chiller, you might have some kind of other dirt, dust, etc. And it's very, very difficult to distinguish what is actually white haze, what is, for example, a fingerprint. And now the technological development that really kind of helped to solve this issue was artificial intelligence. And I know that's really a kind of a hype buzzword nowadays, but it really came to play. So we started to test with these different kinds of neural networks, how can we teach them to actually detect white haze. And in the end, we noticed that the model started to learn it started to really learn how to separate what is a fingerprint, what is dust, what is actually white haze. And after that, we decided that, okay, this is really the approach to solve the very, very difficult issue. And now over the last couple of years, we have been training the model with thousands and thousands of images from different locations using this categorization, mild, medium, and strong. And after all of this work, we can now say that the model is really reliably detecting white haze, and only detecting white haze, not mistaking it for anything else in tempered glass. And you already saw the picture of the scanner from Peter, but basically the idea is that the hardware can be placed right after the tempering line exit. So the scanner itself, you can see here, this kind of a small box after the bigger structure. So right at the exit of the conveyor or the tempering line, and that of course means that all of the glasses that you temper are automatically scanned. And what the scanner then gives out is that here you have an image of the loading that was just scanned. So 4 glasses coming out of the tempering line, and the system is automatically now highlighting where white hazes have been detected if they are there. So now in this example, the system has detected a couple of medium hazes, which would be these orange ones, and then 3 or actually 4 blue hazes, which are mild categories. And this information is then automatically available to the tempering line operators. And of course, you can set certain parameters that you're having automatic alerts if, for example, strong hazes are found and you want to react to this immediately. So step 2 is now solved. So we are able to get a high quality image of white haze. We're able to detect white haze from the tempered glass automatically. And now the next question that unfortunately I don't have an answer to yet is that how do we move forward together as an industry towards a standard of white haze? So now there's actually a way to objectively discuss about white haze. There's a way to move towards a standard, so we don't need to gather tempering line operators in a boxing ring to fight that who did the best haze or worst haze and how it's evaluated. So now, next challenge for us. There's finally a solution for automatically detecting haze. Next question is then that what do we do with the information? Thank you.